Thinking about colligative properties, and we have two more that we want to discuss before you go to lab. So the next thing is to look at Raoult's law and think about what happens if we make a mixture of two things that are volatile. We looked at what happens to a non-volatile solute in a volatile solvent. Now we're going to say what happens if I have two of them. We know from Chem 111, from Dalton's law of partial pressure, that the total pressure of any mixture is the pressure of A plus the pressure of B. So if we have a mixture of volatile solvents, the vapor pressure of A plus the vapor pressure of B would be equal to the total vapor pressure over the mixture. And we know that the vapor pressure of A is equal to the mole fraction of A times the P0, the pressure of pure A. Sounds like a cooking class. And the pressure of B is equal to the mole fraction of B times the pressure of pure B. So what that means is that the total pressure is going to be equal to the mole fraction of A times the pressure of pure A plus the mole fraction of B times the pressure of pure B. So when we have two volatile components, all we need to do is add them together. So we're going to have to go through and do these calculations. Now, for whatever reason, I don't have this page in my notes with these worked out ahead of time. So I don't know why. I need you to grab your calculators and help me. We're going to work through these together. Okay, so when we look at this one, we know that the vapor pressure of cyclohexane is 66.9 torr at 20 degrees, and the vapor pressure of toluene is 21.1 torr at the same temperature. What is the vapor pressure of a solution made of the two solvents when the mole fraction of each one is 0.50? Well, we look at this and say, okay, I know that the total pressure of the solution is equal to the mole fraction of the cyclohexane times the pressure of the pure cyclohexane plus the mole fraction of the toluene times the pressure of the pure toluene. Now it says the mole fraction of each one is 0.5, so this is a little bit easier problem because I don't have to go through and calculate mole fractions, changing masses into moles. So that means the mole fraction of the cyclohexane is 0.500 times the pressure of pure cyclohexane, 66.9 torr, plus the mole fraction of the toluene, also 0.500, times its pressure, which is 21.1 torr. So now grab your calculators. The mole fraction of the solution is equal to whatever this is. What is it? A half of that? 44? Oh. 33.45, and we know that we have to stop at 3 sig figs, so we're going to stop here after we're done adding. And this one is what? 10.55? And again, we have to stop with 3 sig figs. So now, Presley, what was that number when you add them together? 44.0. Yeah, it is when we stop here, torr. So I don't think these are very difficult. When you look at this, we're using the same concept we've just practiced, and we go through and add things together. Yes? Theoretically, it is most correct to leave all your sig figs and round once at the end. Now, that's not what I do, because in class, if I start writing out 8 digits from your calculator, that gets really cumbersome. So what you see me do in class is to round at each step. Since I didn't have a calculator and I was dividing these in my head, I just went ahead and wrote down the digits from dividing in my head. but I marked that I needed to stop here. So whether you do it all at once and round at the end, or whether you round at each step, you will get slightly different answers. That's the normal variation we expect from sig figs. So I don't really care which way you do it. I guess that's the answer to your question. I don't care. 44.1 would be a perfectly acceptable answer. Okay, go ahead now. Just do the next one at your seats.